belong to certain soil condition. Right? So for example, this is definitely sand all the way to the organic soil. So when you plot like this, you know roughly what the soil condition is, right? Or sorry, what the soil type is, yeah? You have some idea, right, already, right? Rather than having to plot one by one, which is more correct, but it's more tedious. You can't automate the process. So for example, I can just bring this up. So this is clay, silty clay. Yeah, same. This one is silty clay, clay to silty clay, and this is like silty sand or sandy silt, something like that. This part also is sand mixture. Then we will have clay at deeper depths. Yeah. So from this IC, you know what the soil type is, right? Okay. Yeah. So when you have to derive the design soil profile, remember you have to divide soil into various layers of distinct behavior, right? Okay. So at least from here you can tell. Okay. So this one definitely different soil type from here. Yeah. Maybe if I use this example, it's too easy for you. I use another example. Totally different. Okay. But this is more complicated. So we have this layer, we have this layer, we have this layer, and so on and so forth. Right? At least that is your first consideration if you want to divide into certain layers. Yeah. Okay. And then later on, you look into the strength, because although maybe the soil type is the same, but the strength can be different, right? Yeah. Then you look into the strength. Okay. So, but as a first cut, at least you can make soil profiling based on the soil type. Before going into strength, the problem is that, okay, you can get soil type from CPT, but how do you know it's correct? Because you don't see the sample, right? Yeah, this is based on empirical correlation. That's why we have this lab test data. Okay, so for example, I don't make it up here. This is from another project. So for example, if you have a few CPT, at the same time you will have sampling borrow as well. Okay, so we want to confirm this, and also we want to have a more detailed description. For example, based on this is silty sand and sandy silt, but which one is more correct? Is it silty sand or sandy silt? We won't know from this kind of categorization, yeah. Or for example, this one clay silt to silty clay. So which one? Because the behavior is different, right? So that's why we have to go back to the lab test data. Yeah, we have to go back to the lab test data. Okay. So now, what should we do? Yeah, when we receive the lab test data. Okay, first of all, going back to what I discussed during the lectures, normally we are only interested whether it's clay or sand, right? Because if you know it is clay or clay, basically you can use CU as a shear strength parameters. If it is sand, it is what we call friction angle, right? Yeah, right. So clay, sand. So for us as an engineer, we just want to know whether we should be dealing with clay or dealing with clay, sand. Yeah, we don't want to deal with something in between because it will be too complicated. Right? This is what we call idealization. Yeah, because the behavior is like extremely different. Okay. But the next question is that how do we know whether it's clay or sand? Because in reality, it can be silty clay, sandy silt, whatever, you know, right? The spectrum is quite wide, but we still want to have this distinction, clear distinction. So that's why we have what we call fine grain. Okay, so this is silt and clay as the major component, yeah. And this is coarse grain. So the major component is sand and gravel. What I mean by major component is because the soil is always a mixture, right? There is a clay, silt component, there is sand component, and so on. Yeah. But we want to identify which one is the most dominant, because when the soil falls under fine grain material, basically you can rely on the undrained behavior, CU. Okay, and this one is say friction angle. Okay. So from the lab test, we have this. Okay, from the CPT, we know roughly, yeah, what the soil type is, right? But we need to confirm with the lab test data, because the lab test data should be more accurate for soil identification. So if you are given this particle size analysis result, okay, this is percentage smaller than. So for example, for A, yeah, okay, for A, okay, so 70% or 75% are gravel size. The remaining is sand. Yeah. So what do you call it? Sandy gravel or gravelly sand? Now we are in the coarse grain regime. Yeah?
Gravel.
Huh? Sandy gravel, right? Yeah? Sandy gravel, right? Okay. So now look at B. Okay. This is pure sand. Right? Yeah? Okay. Because it's very narrow. This is like most of the particle is of similar size. Yeah, pure sand. So this is sandy gravel. Now when it comes to C, this one, like you have silt, you have sand, you have gravel. So how do you define? This is the problem, right? Okay. But we have convention. If the fine content, what I mean by fine content is this one 0.063. Why 0.063? Because that is the smallest particle size that is still visible by naked eyes. If you are talking about 0.001, you can't see. Yeah, 0.063, something that you still can see. How small it is. Okay, so that's why we call it fine particles. For those below 0.060 mm in diameter. So this is fine content. So if the fine content is more than 35%, you can assume that your soil in general will behave as a fine grain material, where you can rely on CU. Okay, the logic is that why 35? Because 35 is on the lower side, right? But the logic is that let's say you have a big particle, and then you have this fine particle as a filler. Okay, if your filler is at least 35%, okay, when you load the soil, basically it will be difficult for excess pore pressure to dissipate, right? Because your filler is like very impermeable. Yeah, so the overall behavior is undrained. That is the logic. Yeah? So the overall behavior is undrained. Although your fine content is only 35%, because naturally, well, I thought it must be at least 50%, right? Right? I mean, based on the gradation alone, yeah, proportion, right? If it is more than 50%, well, the majority will be the fine content. But no, it's not the case. It's 35%, according to British standard or Eurocode. So that means when you have 35% of fine content as a filler, basically the overall behavior of this soil will be undrained when it's loaded. Okay? So that's why this is very important. Yeah, the fine content. Okay, so in this case, if you look at C, okay, this is say around, let's say take it as 35. Okay, so at least we know that this is. Oh, another thing is that British standard. Okay, based on the gradation itself, you don't have to distinguish silt or clay. We will go to the next step later on. So at least you know that for C, it will be say sandy or gravelly, sandy gravelly silt or sandy gravelly clay, right? Now the clay becomes the major component because the fine components, sorry, the fine content is already 35%. So of course D is straightforward, right? This is the fine content, right? So the fine content is like all the way 100%. So definitely this is pure silt or pure clay. Yeah, so you understand, yeah? I will come back to that later on. So now the next thing is that how do we determine whether it is clay or silt? Yeah. Of course, you can do what we call hydrometer analysis to break it down, right? Because from the particle size analysis, you do not know. Basically, you cannot extend this. This is from using the sieve, right? But for clay, it's too small that you cannot sieve it. So you will have to do the hydrometer test. But even if you don't do hydrometer test, you can use this chart. You know, this is Atterberg limit, right? So based on the, you know what plasticity index is? What is plasticity index? LL minus PL. Okay. So if you plot PI versus LL, okay, you know, if you are below this line, you are silt, N is silt. If you are above, you are clay. This is, of course, this is other crude, but this is quick. Okay? Yeah? And of course, you can also identify whether it is high plasticity or low plasticity and so on. Okay? Yeah? So, but at least, what I expect from you is, if you know this, going back to the actual lab test data, I will change this graph later on. Example, for the first 5 meter, yeah, we are not really sure what the soil type is, right? Can be silty sand or sandy silt, whatever. But then if you look at the lab test data, you have this, right? So that means sand is 72%. Okay, silt and clay is 28%. Or at 6 meters, sand is 89%, clay is 11%. So you know, yeah, you know whether it is, what is the primary identifier? Is it like sand or silt or clay or silt? Sand, right? So it can be silty, clay, sand, or something. Yeah. Okay. So this is something that is very difficult to explain in a textbook, but this is how, this is the step basically. Yeah. So once you know from CPT, you know roughly what the soil type is, and then you check from the lab test Okay, what is the percentage of sand? What is the percentage? This is fine content, by the way, right? And you know which one is higher than the others. Yeah. Okay, and also you can plot. For example, this one we don't have attribute limit, right? For example, if we check here, so 28, PI is 11. 11 and 28. 11 and 28. So it could be clay of low toxicity. So your description will be clay sand, right? Clay sand, right? Because initially from here, from the gradation curve, this can be clay sand or silty sand, correct? So now you have to decide whether it's silt or clay as the secondary identifier, right? So based on this, the adjacent borehole, we have attribute limits, right? Okay, and then you plot here 11, 28 table. You are slightly above this line, so clay basically. Okay, so that's why if you notice here in the borehole, you will read all these things, right? But maybe you are wondering how they come up with all this long description. Yes, that's what they do. Yeah. Of course, if you don't have CPT tests, you simply rely on this. You simply rely on this. Okay. I'm not sure whether it's clear enough, but I know this is not so straightforward. It takes some judgment, right? But at least now you know the step is clear. That first you go to this particle size analysis. Okay, you refer to the particle size analysis, and then at least you know what is the primary component, yeah, whether it is sand, gravel, or fine material, clay, and silt. And then if the fine content is more than 35%, you want to distinguish whether it is the primary component is clay or silt, then you do this. That's why in the lab CE3116, you do this, right? You always do this, right? Remember? In the lab test, definitely you do this. But don't tell me you didn't do this, yeah? Definitely you do this, you know. Huh? Grain size analysis? No? Are you sure? Then what kind of test do you do?
Grain size. Sorry.
Oh, they give you?
You only need to do the CH one.
Oh, you only do this? Wow, it's unfortunate. Yeah. When I did my MBA, I do everything. No choice. I cannot choose. Okay? So never mind. You don't have to do this yourself. But at least you know how to read, yeah? Or you know how to use this. Okay? You don't have to do this yourself. Okay? But you know how to read this. Because otherwise, because in any soil report, you will always see this. So don't throw, eh? Sometimes maybe there is a mismatch between borehole and this information. Okay, never mind. Now you don't need to do this. You just need to rate, and even you don't need to rate. I only give you the percentage. So again, that makes everything more straightforward. And also now at least you know why the reason why you do this. Yeah. Okay. When I was student, I also don't understand what's going on. You know, I just do. My lecturer also don't tell me how to use this. Okay. So, but at least now you know. This is an index kind of test. Yeah. Without having to do hydrometer test. Because in Singapore especially, we don't always do hydrometer test. Okay, but at least you can rely on this to know whether you are sealed or closed. Okay. So now going back to the design soil profile. Okay. So now you know how many layers that roughly you need to go, right? It's simply based on the soil type alone. Of course, you don't want to every spike you have one layer. I mean, what's the point? Right? Remember, the foundation is 20 meter, So if your layer is like 0.1 meter thick, I mean, what's the point? It won't change anything, right? So this is typically the tendency. If you think that you can make things more accurate by having many layers, it's wrong. Yeah, but of course, on the other hand, don't give me one layer. That means you are lazy, You just give me one layer. Okay? So there must be a sweet spot there. Remember, if the foundation size is 20 meter, so how deep do you need to go? If your soil profile only cover 10 meter, and your foundation is 20 meter, definitely it's wrong, right? So go back to lecture note. Minimum, what is the, I would say, a soil model that you have to, the extent of the soil model you have to have. Right? Okay? There are not many layers, honestly. That's why I choose very simple one. It looks complicated, but the design profile is very simple. Okay? Right? Okay, the next thing is, now let's say you make decision already, yeah? Okay, I want to count with certain layer now. I won't tell you, it's too easy. Okay, so now, how about the strength? Definitely you need strength, right? Where do you get the strength from? From what? CPT? Yeah? Yeah? And also from lab test, right? You do traction, you got UU, okay, for clay, yeah? So for example, this one clay, yeah? This one clay, right? This is clay, yeah? This is clay region, yeah? So this is clay. So you do UU test, okay? You do UU test. And then you can calibrate your CPT, right? Using the NKT value, remember? Yeah? All the while the NKT is given, right? For this also I give you already. So basically, why do we still make CPT? Yeah? You already have UU, right? Remember, yeah, UU is at a certain point, discrete point. If you need continuous profile, definitely CPT will complement. Now I think now you should appreciate more that why institute testing and lab tests complement each other. So this is ideal, you have plenty of UU points there. In reality, maybe you only have 5 or 10. Then how do you know in between whether you can draw a straight line or not? That's why if you have CPT, at least you can get the trend. Imagine if I say, well, this is straightforward, but imagine if there is any spike, for example here, and you only have 2 points, UU point without CPT, the tendency is that you just draw a straight line, right? But you miss this layer there, which can be totally different strength. That's why I like CPT. Okay? I'm CPT man, but not con man. At least I'm not con man. I'm not con man. Okay, so that's why. Okay, going back to this. So you have UU test, and then you do the student methods thing. I don't ask you to do it. It's just, well, it's not really complicated, but I don't want you to focus on that. This is the student method for linearly increasing trend. What you have done, the early part is just constant strength, right? So if you apply the method that you learned, you will have constant strength, yeah? Right? But because by looking at this point, you know that the trend is increasing, right? So you want, when you do your student test, student method, basically you make sure that you capture the trend as well. Yeah. So this is the characteristic value. So at least now you understand how this student method is implemented, right? So from this dot, because otherwise how do you derive the profile? You know, it can be anything, right? Or at least you can do regression if you want. Forget about student method, maybe you don't have time. Just do Excel regression from this line. Okay? Right, so from UU test, you got this. Okay, and then if you combine with CPT, you have even more complete pictures. Right? Okay? So from here you can decide. For example, well, this is lower than the overall trend, yeah? Maybe I want to treat this separately. Slightly lower strength. Or, well, this is too thin anyway. Just take the whole thing as one layer. Okay? Clear, yeah? Up to this point. Okay? Don't give me one layer. Don't give me 10 layers also. Okay? Huh? I know. I mean, this is not. This is too difficult for the exam. Definitely, it won't come out with the exam. But the reason why I think this is good for you is this is what geotech is all about to me. It's how you can exercise your judgment, and you make sure that your team members also agree, or even if they disagree, fine. But you must come up with one. You know, that is the same thing. When I was working, you know, there's always two persons who check my design profile. Let's say I derive design soil profile myself. There are always two other colleagues check. They must agree. If they don't agree, they give me something that I can agree. You know, because if three of us don't agree with each other, then project will never move on. You know. Okay, so this exercise is mainly on making judgment and then agree on something. Okay. So that's why I purposely make the table simple. It's about the process, it's not about the end result at your level. So now, after we got this, roughly, at least for strength and soil type, we can link the two, right? Yeah, we can have a soil profile and so on. So once you decide, I think the rest you must follow same profile. Don't tell me, you know, okay, for soil type and strength, I have, say, 6 layers, but for other parameters, I have 10 layers. No, it doesn't make sense. Yeah. Again, going back to idealization, right? Just assume that the wall is horizontal, yeah? In fact, it's not horizontal. That's why, yeah, in reality, this will be 3-dimensional because I think you have seen I think when you do your design project A or B, right? There's some variation as well. Right? Okay, but now let's assume that it's horizontal. So you have layer 1, 2, 3, 4, 5, and you have parameter 1, 2, 3, 4, 5. Right? And then you will have, this is parameter type, eh? Right? And then you will have the same thing here. Okay? So what is the parameter we need for shallow foundation bearing capacity? You know what to do, yeah? Okay? We go back to preference node. It's not many. For sure, what do you need? Eh? Beyond shear strength. What do you need? Quickly, exam is coming, you know. You need, wait, correct? Correct, yeah? course, without unit weight, how do you calculate bearing capacity? Remember, my shallow foundation here is embedded, 5 meter, right? So I need to know overburden. Correct? Without unit weight, how do I work out overburden? Yeah? So at least you have overburden, you have what? Shear strength parameters, right? And then you can calculate bearing capacity. And exam is coming, yeah? So basically this design project link everything together. Okay? Because later on, I can tell you, yeah, when you work later on, sometimes you don't have time to go back to your calculator, must be in your head. For example, what is the clay bearing capacity? 6 times CU, right? So at least roughly if this is the shear strength, this is my structural load, average, let's say 100 kPa. What is the minimum CU I need to have? 20, right? Correct? If my bearing pressure is 100 kPa, okay, what is the minimum strength do I need? Remember, QU equal to 6 times CU, right? Okay, for clay, right? So minimum is 20 kPa. If your soil contractor tell you, the soil is 40 kPa, I know you can sleep well. So very quick, you don't have time to go back to your calculator or computer. At least you can make decision on the spot. Okay? So same thing, when I ask you what parameter you need to do bearing capacity calculation, at least you know. I don't ask you to calculate bearing capacity, right? I only ask you what parameter do you need. So, shear strength and what? Gamma. Okay? And then, what do you need to do settlement calculation? Huh? A, B, C, D, E, F, G? Huh? E, right? E, right? So, but we don't have E here. What can we do? Constraint modulus. Normally E is not given. They give you M because they also do odometer test, right? In the lab. So how do you correlate M to E? I give you this. Yeah? But you need Poisson ratio. So what Poisson ratio to use? For sand and clay, you Google. You see now I give you all the clue already. Too many clues. For settlement, you need to have stiffness parameters, right? E, right? Okay? Huh? Don't give me those faces. You look all good. Huh?
GG.
Huh?
GG.
Is it too complicated? No, I give you all the steps, right? I won't give you very low score, you definitely know I appreciate all your effort, yeah. But I want you to understand the process and the decision making. Okay? That's why I only ask you to write a page report. Only a page. Don't give me more. Okay, so for example, going back to this, yeah. Example for this layer, you can draw something, okay. Say you want to treat this as one layer, let's say, what is your M? Let's say your M is, say for example, 1.5 MPa.
So across all the parameters you use the layers.
Okay, you assume certain Poisson ratio and then you got E.
When you use M, then you split into layers.
So you know gamma, you know
use the
CU,
M.
you know friction
Then
angle,
use another
you know
set of
Poisson ratio, you know E. Do you think you can calculate the U, LS and SLS already? Huh? Can, right? Huh? See? You got all the answer. Oh my god. I give you everything, too much. Okay? So you answer A and B already. You answered A and B already. only 30 minutes, you know. I give you 4 hours. A and B answer, yeah, 30 minutes. Okay, now the next thing is the gap. Okay. So, for example, if you think that this E, yeah, this E is too uncertain for you, because first you convert CPT raw data to M. Then from M you do correlation to E. For you, well, this is too uncertain because there are too many correlation. So, but to me, to you is very important one. So, what do I need to do to get more accurate E? In situ test, for example, you know what to do. Lab test, you know what to do. So, done. So this link everything together, right? From what you learn from Prof. Darren, yeah. As a design engineer, you know what you need to do foundation design, because maybe later on when you work, your job is not to design foundation, but your role is to derive this parameter, right? Which is more expensive, yeah, than designing foundation. Because designing foundation many people can do. Yeah, but coming up with a sensible parameter is another skill. So your pay is more. Okay. So at least you know, for you to do design, you know what parameter you need to get, and when you get all these parameters, and if you are given raw data, you know what to do. So basically, this link everything together nicely. So I think you are ready to be a geotech. With these big pictures, yeah, I think you are ready to be a geotech. Of course, the rest you have to learn by doing. But if you understand the whole process, you are ready. Okay. So from raw data you interpret, you come up, you simplify the condition, you give a required parameter to do the design. Either you do design yourself or you let other people do. That's it, you know. So whether you are working as owner engineers, whether you are working as consultant or contractor, if you understand this whole process, you are good. Okay? Because if you are only given parameter, you won't appreciate how hard it is to get this parameter. Maybe as owner engineer, because you do not know all this process, you ask your contractor to get more, you know, but because you don't appreciate how difficult it is. Yeah, or sometimes, you know, you are given a range, but you only want to have one number, you know, for example. Sometimes it's also impossible. Yeah. For example, for this correlation, yeah, I only use one correlation. What if I use two correlation? There are thousands of correlation, you know, between CPT and other parameters. Yeah. So I can have thousands of curves. So maybe somebody will give you a range, but at least you know why. It's not just a single number. Depending on the correlation you choose. Okay, so are you ready? Ready, yeah? No choice. Hey, this is 10 points, you know. Right? Teamwork some more. And you have 2 weeks. I know, maybe to some, this is useless exercise, but I guarantee later on when you work as geotech, you will know. Okay? If you choose to do geotech. Even if you don't choose to be geotech, doesn't matter. At least you understand the language. So nobody can pawn you. Okay, So if our submission is on the 17th, right? If you are still totally blurred, next week we have the tutorial. If you still want me to confuse you even more. Yeah? Okay? Now I'm helping you to get 10 points beyond exam. And more importantly, this is your life skill. can make money, you know. I don't teach something complicated, I teach you something that can make money. I can't think, I do not know complicated stuff anyway. Okay?